This video is going to discuss collisions between galaxies. And one sort of starting question would be, why would astronomers expect galaxies to collide more often than stars collide? I'd give that a little bit of thought. Think about how big a star is, how much space between stars, how big a galaxy is, and what's the spacing of galaxies. And considering those questions, we can come up with a good answer to the questions presented here. And to give us a little background on this subject, what about star collisions? Well, if you would consider the size of a star, the diameter of a star, and the distance between neighboring stars, roughly in our region of the galaxy, we'll find that there's about 1,000,000 times the diameter of a star in between the stars. You could fit in 1,000,000 stars in between the average two stars and how far they're separated. So as stars would move past each other, it's really unlikely that they're going to collide. The gravitational attraction is not that great. Gravity is a weak force, so they're not going to be pulling each other into some meeting. Galaxies, on the other hand, when we take a look at a galaxy cluster, we find that the galaxies there are only about 20, maybe 30 times the diameter of the galaxy away from each other. So not 1,000,000 spacing, but only 20 size of the object spacing. And that provides much more opportunity for targets to collide. The galaxies are much closer together than the stars, for the size of the objects that we're dealing with. The galaxies are close enough together to make collisions probable. And this slide shows some galaxies in the process of colliding. We can see how gas has been distorted. There's kind of a gas bridge here with material being pulled away. Spiral galaxy, barred spiral. And when this happens, some things to consider. Should be answering this very quickly based on the previous discussion. When the galaxies collide with each other, what's more likely to collide, the stars, the gas and dust, or the black holes? Well, you need to consider which has the more area, which is more spread out and can lead to collisions. And that answer would be the gas and the dust. The gas and the dust. And, there's much more material in air in a room, per cubic centimeter, than there is between the stars, gas and dust in a galaxy. But it's kind of analogous here. We have collisions in the air molecules in a room, and there are going to be collisions between the gas and the dust that occupies a great area. Not as much spacing between those as between the stars. So the gas and dust is going to collide, and that can actually lead to star formation. As the gas and dust compresses each other, we can have new stars forming. But this particular one, NGC, New Galactic Catalog 6050, shows two galaxies interacting. Here's Stephan's quintet. The kind of yellowish galaxies are further away and have been redshifted somewhat. This galaxy is closer to us than the other members here. But if you look in the middle, you can especially see the results of the collision that happened, I don't know how long ago, a great deal of time ago. We're seeing it now. And we've got one nucleus here, another nucleus here. You can see material that's been, for gravitational forces, been tossed out and away from its nucleus. So there is this effect, and galaxies do collide. Here's some other examples of interacting galaxies or colliding galaxies. And again, you can see some distortion, great distortion in some of these as the galaxies pass by each other and pass through each other. We can get these great examples of gas and stars being pulled away from where they used to be and destroying the spiral shapes that the galaxies used to have. So for the Andromeda and Milky Way galaxy, we're on track for a collision in about 4 billion years. It's going to be a great show, I'm sure. It will happen very slowly, but the two galaxies are moving together. They're going to meet in the middle here someplace. The Milky Way is going to travel farther than the Andromeda Galaxy because the Milky Way is less massive. The Andromeda Galaxy is going to move less. The lighter object moves more with the gravitational force being present here. So that's going to happen in about 4 billion years, and the two galaxies will pass through each other and come back, and gas and dust will be creating new stars. It'll be a great show. Here's some speculation on what this would look like if we were watching this happen on the sky. As the Milky Way gets closer, the Andromeda Galaxy, I should say, the Andromeda Galaxy to start with is here, and gets closer to us, and then great amount of distortion takes place as the two rims of the galaxy overlap each other, and then coming down to an elliptical galaxy after the collision is finished, a nice smooth distribution. There is evidence that this has happened in the Andromeda Galaxy in the past. The Andromeda Galaxy has two nuclei. It's a double nucleus. So we have an object here, black hole, another black hole here, and this could have been from a galaxy that was absorbed by the Andromeda Galaxy sometime in the past. So there is a YouTube video that this is a link to. I'm not going to play it in this video, but if you do go to YouTube and do a search for Hubblecast episode 55, you'll see a computer animation of the collision of the Andromeda and Milky Way galaxies. It's worth a view. So astronomers think that the collisions do produce elliptical galaxies. And we look at clusters of galaxies in the central region where the density is higher and there's less spacing between the galaxies and collisions are more frequent. We find elliptical galaxies there, not spirals. And the idea is the spiral galaxies have collided, have distorted, regathered gas and dust. The gas and dust is formed into stars to remove gas and dust from the two components, and we get an elliptical galaxy that's lacking gas and dust and lacking star formation. These clusters, we do have spiral galaxies on the edge of these great galactic clusters where there are thousands of galaxies loosely held by gravity, and dark matter playing a role in that, and we'll go into that in this video. But these collisions are thought to create the elliptical galaxies. So you should be writing down some questions and asking your instructor, read some good resources, watch some YouTube videos. That's all for now.